let's actually write some classes. First one we're going to consider is the student class. We'll write it later in this unit, but we'll start by considering it from the client perspective. That is, from the perspective of some object that is using an instance of the student class. Later on, we'll actually take a look at the implementation, or what you'd see from the server's perspective. So for now, from the client perspective, all we need to know really is that a student object holds a name and 3 test scores, and it responds to the following messages. In other words, it has the following methods, and this is what they do. Take a second, pause this video, and look through these quickly. Let's do a lightning speed trip through each of these methods. We can see we have a method called setName. It doesn't return anything, and it takes a string as a parameter. Here's how we might use it. Stu, if Stu is our student object, stu.setName Bill. We pass it a parameter, Bill, which is the name we want this student to have, and then it sets the instance variable of the student's name to Bill. We have a method called getName, which returns a string. Here's how we might use it. We take our student object, we call getName, and it'll return the name of that student object. For instance, if it had been Bill from the method before, we can store that then in a string. We could print it out. We could do whatever we'd like with it. Now remember, a student object holds 3 test scores, so we can also call a method called setScore. SetScore doesn't actually return anything. You can see its return type is void, but it does take 2 parameters. The first one specifying which of the 3 tests we want to change, the second specifying what score we want to give it. Example, stu.setScore, we pass it 3 to indicate we want to change the 3rd test, and we want to set its score to 95. We can see that it will default to 3 if which test is anything other than 1, 2, or 3. We have a method called getScore, which takes a single parameter, whichever test we want to get, 1, 2, or 3, and it returns as an int the score that we requested. So here you can see an example usage, stu.getScore, pass it 3 to indicate we want the 3rd test score, and whatever is returned from this method call we can assign to a variable. We could do whatever we'd like with it. Again, in this case, if which test is not 1, 2, or 3, then we automatically substitute 3. That's just a decision that the writer of this class chose. We have a getAverageScore returns an int, the average test score, that is the average of the 3 test scores that this student has. So we have stu.getAverage, our object, and then the method name, it'll return the average of the test scores. In this case, we're storing it in a variable called average. GetHighScore will return the highest score, that is the highest of those 3 variables, those 3 test scores that the student object remembers. And finally, toString, which returns a string containing the student's name and test scores. We'll talk more about toString methods later. Essentially, we're getting a string representation of this object. And in this case, we're storing that string representation, which we've decided is the name and the test scores. We're storing that string representation to some variable called str. That's just a lightning speed introduction to what each of these methods does. So let's take a look at some code that actually shows us how a client would instantiate and use student objects. First, we can declare some variables, including 2 variables of the type student. Note we haven't yet made objects. All we've done is declare variables, s1 and s2, which are of the student type. We also declare a string called str and an int called I. We're not going to use those variables until we've actually assigned them initial values. So here we assign a new student object to s1. Remember, we're using the operator new, that reserved word. So this is an important time to refresh your memory. S1 is a reference to a student object. It is not itself a student object. It's a variable pointing to a student object. Now we know that a student object keeps track of the name and the test scores of some actual student. So for a brand new student object, the question is, what are the values of those attributes? What are the values of the name and the 3 test scores by default? That depends on how the class itself is implemented internally, but we could find out by calling methods in the student object using the variable s1. Here you can see we do s1.getName and we store its return value, its output, to str. If you print it out, we would see that the default name for a student object is the empty string. It shows us nothing. Same for highScore. It looks like if we call s1.getHighScore, assign it to a variable I, which we'll assume is some int, as declared from the previous slide. And if we print that out, we would see 0. So it looks like the default score is 0. And when we were asked to find the highest of those 3 scores, well, they were all the same. So maybe we want to actually use the student object. We want to call those methods. Well, here's how we might do it if we wanted to set those attributes. s1.setName, pass it Bill, s1.setScore, that's 1 and 84, so we want to set test1 to 84, we'll set test2 to 86, and test3 to 88. Note that we're not actually assigning any values using an assignment statement here. The return type, if you go back to that prior slide, the return type for setName and setScore, the return type was void. So there's nothing here to assign, there's no output here to assign to any variable. All we're doing is changing the internal state of S1, the internal state of that object that we're working with. Because these methods are changing an object's state, we call them mutators. In other words, they're mutating the object state. They're changing it. Sometimes we'll commonly refer to them as setters because they're setting the value of an object's instance variables. Likewise, we can have methods that access but don't change an object's instance variables. Those we would call accessors or getters. So mutators and setters change instance variables. Accessors and getters get instance variables. Here's an example of some getters. The convention is actually to use the word get in the name of the method. So we have s1.getName. We're not changing that object's name variable. All we're doing is extracting its value. We're just getting it. So in this case, we could assign the output to some variable str. And here you can see in the next 3 lines, we're getting score 1, assigning it to I. Getting the high score, assigning it to I. Getting the average score, assigning it to I. These are accessing the values that comprise this student object's state. Finally, if I call the toString method, we can see what actually gets returned. So in this case, I'm saying s1.toString, whatever this method outputs will store to str. And below you can see the value of str after this call to toString. It's name, Bill, new line, test1 84, new line, test2 86, new line, test3 88, new line, average 86. If you were to print this out, you'd see that it expanded to several different lines because of the new line characters that we have there. In fact, here's what that output will look like in the console if I run a little program just printing out s1.toString. Now, in that last slide, I explicitly called my toString method. I did s1.toString. But there are other situations where the toString method actually gets called automatically or implicitly. As an example, if I try to concatenate a string with an object, we end up with an implicit call of toString. Same happens if I try to pass an object to the method println. So in both of those cases, we get an implicit call to toString and we end up with our string version of that object. This is actually really helpful. It's kind of nifty. So because toString is often very helpful and it has this sort of built-in implicit functionality, we will very often include a toString method whenever we write a class, whenever we define a particular type of object. If you don't explicitly define the toString method, then Java will actually provide a very, very simple version of toString, but it's not very useful. It basically returns essentially the name of the class. There's a little bit more information, but we'll talk about what exactly that is a little bit later. Just the key takeaway here is writing your own toString method, very, very helpful. Last thing we'll discuss for this little part of the demo is what happens when we associate a student object with some other student variable like s2. So you can see in this statement here, assume we have these student variables s1 and s2. s1 is actually tied to an object. It actually refers to a student object. If we do this assignment statement, s2 gets s1, well now what happens is both s2 and s1 refer directly to the same student object. You might hope that it would go differently. You might hope that actually we would just get a second new student object, but that's not what happens. Let's just take a look pictorially at what is going on here. When I instantiate a new student object, like we see in the line of code here, student s1 equals new student, I actually make a brand new student object and then I assign it to s1. Then when I do this assignment statement, student s2 gets s1, now I have, again, 2 separate student variables pointing to the same student object. We don't get a second new student object with identical state. We have 2 references to the exact same object. Cannot stress this enough. In fact, if I were to set S2's name to Anne and then get the name through S1, we would see that after this line of code ran, str would hold the value Anne, no longer Bill. Both of these variables refer to the same object, and we can use either one to mutate or access its state. Likewise, I can also sever the connection between a particular variable and its object that it is pointing to. So in this case, I've set S1 to null. Now S1 doesn't point to anything, but we do still have S2 referring to this object. This object won't yet get garbage collected because there's still a variable pointing to it, S2. But if I were to set S2 to null, then this object would disappear. It would go to the trash because now there's nothing pointing to it in my program. Nobody can use it. Pause this video and pick through this diagram a little bit so you can understand the differences in assignment statements between primitive data like ints and reference types like students. You can see here, if I declare two ints, I and j, I set I to be equal to 3, and then I set j to be equal to I, we have two separate copies. That's what happens with primitive data types. With objects, we get a different situation as we discussed in the past few slides. If I declare students s and t, I give s a brand new student object, and then I set t equals s, I don't get a copy. Once again, I do not get a copy. I get two references to the same object. That's a distinction between primitive types and reference types. So maybe that deserves a little bit more attention. Earlier in the class, we did mention the fact that in Java, all types are either primitive types or reference types. Primitive types examples are int, double, boolean, char, and long, float, all those kinds of things. Reference types, on the other hand, are all classes. So examples of that are string, student, scanner, random, AP image, all those different things. It's best to think of variables of these two different types, that is, of primitive types or reference types. It's best to think of them slightly differently. A primitive type variable, you might think of it like a sticky note or like a box where you might stick in a numerical value, say like 16, if your variable were like this age variable, this int. If it's a variable of a reference type, we really think of it as a box that contains a pointer to an object. So this variable S1 really just contains the address of this larger student object that we've created. So that's a distinction between a variable of a primitive type and a variable of a reference type. So if I were to run this little chunk of code, int number equals 45 and string word gets high, well, look what we end up with. We end up with a variable called number, which is this little primitive variable, this box, which itself holds the number 45, whereas string word gets high ends up with a reference to this object high. Now, reference variables, like word from the previous slide, they can also get the value null. So if you have a reference variable that pointed to an object before and no other variable points to that object, then the computer's memory is going to reclaim that object's memories during garbage collection. That's what happens here. You can see in this picture, we've got a student object, which has the values Mary, 70, 80, 90 to begin with, pointed to by a student variable called student. And then finally, when we set student to null, the connection between the variable and the object is severed. Now nothing points to that object, and it goes to garbage. In this case, the reference variable student is now null. It doesn't point to anything. There's no object there which knows how to do any methods. So after setting a reference variable to null, if I then try to call a method on that reference, I'm going to get what's called a null pointer exception. That's what we see here in the third line of code, student.getAverage. Well, that's not going to work because that object has already been taken to the garbage, or that reference doesn't point to anything. Here's another example of a null pointer exception. If I have string str equals null, right, I haven't given it the empty string, I haven't given it any other string as its initial value. If I try to print str.length, well, str is null. There's no string object there that I can actually use to get the length. So Java is going to throw a null pointer exception. Your program is going to crash, and you're going to weep and gnash your teeth. The answer is to check whether your object references are null if you want to use methods. If there's any reason why you think that a particular object might be null based on the state of your program, you want to just do something like if student equals null, don't do anything. Don't run any methods, and maybe you want to recover from that somehow. Otherwise, you can do whatever you would like. Just know that you're able to do comparisons to null to check whether a particular reference is null itself. That can stop you from getting null pointer exceptions. Okay, so now that we've considered the student class from the perspective of a client, in other words, somebody using a student object, we want to talk about what it will look like on the server side, which is to say how we would write the student class or how we would implement the student class. All classes have a relatively similar structure that includes 4 parts. The first is that class's name and any modifying phrases. For instance, we'll see public, and there might be some others. We also have a description of the instance variables of the class. In other words, the information that instances of this class will keep track of, the attributes that they'll remember. We have constructors, which are a special type of method that we use when we create an object, when we instantiate objects. And we have one or more methods that will specify how an object will do what it does, the methods that define its behaviors. As long as part one, the class's name, the declaration of the class, as long as that comes first, the order doesn't actually matter for the rest, but our convention is going to be to follow this order. The name, then the instance variables, then the constructors, and then all the other methods. In fact, sticking to that order is going to yield a template that looks something like this. We have our class name at the top, our instance variables, all of our constructors, which are those special methods, and all the other methods. Let's talk about each one of them. Now, maybe you're seeing this and it's not clear what this first line means. Public class, name of class, extends some other class. So let's talk about each part. Class definitions are usually going to start with the word public, which means that this class is accessible to any client that wants to use it. There are some alternatives. You might not make a public class in all situations, but we're going to ignore that for now. We'll talk more about it later. Next thing there is the name of the class. And again, these are user-defined symbols, so you got to follow the rules for naming things. Most commonly, we'll start classes with a capital letter, and as you've seen with variable names and method names, we'll start with a lowercase letter for those. There is one exception, which you've seen before, final variables. We typically name those with all capital letters. But for classes, which is what we're talking about right now, start with a single capital letter. And last of all, what might be confusing in this first line, that extends word, it's talking about Java's class hierarchy. We'll spend a great deal of time on this later in the course, but for now, we'll do a sort of surface level understanding. All classes in Java exist in this big hierarchy. When we're speaking generally, we say that we have superclasses and subclasses. So a superclass is above a subclass in the hierarchy, and we would say that a subclass extends a superclass. If it's helpful to think of a genealogical extension, you might say a child extends a parent. Here you might say, in this hierarchy of cars, a Ford extends car, a Toyota extends a car, just as a Focus extends Ford, a Prius extends Toyota, a Camry extends Toyota. In fact, it's sometimes helpful for us to use is a to summarize this relationship. A subclass is a superclass. Or to use our car example here, a Ford is a car, a Toyota is a car, a Focus is a Ford, a Prius is a Toyota. You can see that the hierarchy has limits, right? A Prius is not a Ford. And a car is not necessarily a Toyota. So it's a one-way relationship there too. Every class has exactly one parent, and it can have any number of children. So maybe you're wondering here, well, okay, I can see Prius and Camry have as their parent Toyota, and Toyota has as its parent car, but who is car's superclass? In fact, what is a car? Well, at the root of the entire Java hierarchy is the class object. So for us, in this case, because car is the first class we were defining there, a car is an object. Whenever you don't specify that a class extends some other parent class or some other superclass, it's assumed that it's going right under object. In other words, that class will just be a subclass of object. That's what we get if we omit the extends phrase from a class definition, which for now is what we'll do. We won't really use inheritance, which is what this is describing. We won't use that extends keyword probably for another few months. Just to give you a quick preview though, the reason this is really helpful is that if we extend a class, well, that subclass will inherit all of the characteristics of a superclass. So that means I can define what a car has, and then if I define a Ford as a subclass of car, well, a Ford automatically gets all the stuff that a car had, and then I can add new Ford-specific stuff to the Ford class. Just like I can make a Focus a subclass of Ford, and then a Focus inherits everything from Ford, and by extension, everything from car. That's going to be where the real power here lies. Quick example here, if I have a quadrilateral extending a polygon, well, a quadrilateral is going to get all the properties of a polygon, plus we can restrict the number of sides to 4, because not all polygons have 4 sides. Then I could narrow it a little bit further. I could say, well, okay, a parallelogram is a type of quadrilateral, so parallelogram extends quadrilateral. It gets everything that a quadrilateral had, and therefore also everything that a polygon had, plus we can restrict the sides so that they are 2 pairs of parallel sides. And then I can do the same for rectangle. Well, a rectangle is a special type of parallelogram. I can restrict it so that it's everything that a parallelogram is, plus all the angles are right angles. Take a second, read through the rest of these, and try to think about what a hierarchy might look like in some other realm other than shapes or cars. Moving along, the next thing to look at is the instance variables section. Instance variables, again, are the attributes of an object. They're the specific information, the data that that object will remember about itself. We almost always make them private. We call this information hiding. So that means that someone who's using an instance of the class that we're defining doesn't have direct access to our data, doesn't have direct access to our information. We control how they access our data. That's what making a variable private does. Typically, this is going to mean that in order to get or change our instance variables, they're going to have to go through getters or setters, which we like because it gives us control over what they're doing with the variables. Next up in our general organization, we have constructors, but we'll ignore those for now, and we'll move on straight to the other methods. We'll typically declare methods to be public, and that means outside clients, anyone can use them. Private and public we call visibility modifiers. They determine which clients are allowed to use a particular method. If you omit private and public, what happens is going to vary from situation to situation, but for our purposes, it's mostly going to mean that the method is public by default. Our general practice is going to be to make instance variables private and to make methods public, unless it's just a little helper method that we know nobody outside is ever going to have to call. Now, maybe a quick look at private versus public would be helpful now, just as a preview. You can see here if I make a student variable S and I instantiate a new student object, assign it to S. Well, if I try to access this private variable name, which is Bill, if I try to access the variable name directly, the compiler is going to reject that. We'll see soon in our definition of the student class that the name instance variable is private, but my method setName is public. So I'm allowed to change the value of the instance variable name using the setName method. Again, in this case, the name instance variable is private, so I can't do it directly. The method setName is public, so I can. Now that we've actually seen what the generalized template for a class is going to look like, let's look through the student class, the code itself. Again, though we're super zoomed out right now, I just want to point out to you, we have all four of the parts that we said we would have: the class name and any modifiers, in this case there are none, the instance variables, the constructors, and the other methods. Starting with our declaration of the student class, we have public class student. You can see that we don't actually use the keyword extends, so that means that student is directly under object in the class hierarchy. We omitted that, so that's where it lives in the hierarchy. We have our instance variables. In this case, as we said before, each student object keeps track of its name and 3 test scores. That means a string called name and 3 ints called test1, test2, test3. You can see that we've declared each of these to have a private level of visibility. That means that outside clients can't access these directly. They're going to have to go through getters and setters that we write. That's our general good practice for instance variables. Here we can see our constructor for the student class. Constructors are a little bit different from other methods. We'll talk a little bit more about them in just a moment, but for now, the things I want you to notice here, the job of a constructor is always to initialize the instance variables of a particular object. So in this case, when I make a new student object, I'm initializing its name to the empty string, and I'm initializing each of its test scores, each of those instance variables, to 0. Also note, constructors never have a return type. Our declaration here is just public student. No return type there. Last thing to notice here, do you see how even though I didn't declare name, test1, test2, and test3 in this method specifically, I'm still able to modify them? That's because those 4 variables are instance variables that I defined here outside of any method. So they're accessible to any method inside this class. Note that because they're private, they're not accessible in the same way to any method outside of this class or to any client. But on the server side, inside this class, any method can use or change those variables. Now we have a bunch of other methods. We're going to go through these at lightning speed, one by one. So I want to make sure that you take a few minutes after you watch this video and go through the slides, or you can pause the video as we go to make sure you're reading the code very closely. We're going to talk a lot about this student class, so you got to make sure you're with me and that you're understanding. This first method, setName, it's got a return type of void, so it doesn't actually return anything, and it takes one parameter, a string that we're calling nm. So That means that when you call setName, you have to give it a string parameter, and inside this method, whatever parameter you give it is referred to as nm. All we're doing here is setting our instance variable name to the value that was passed in, or nm. That's how we change the value of the name. GetName, we can see its return type is string, and it doesn't take any parameters. All it does is return the name instance variable. You might be thinking, okay, that's kind of dumb. If all this getter does is return the name, why wouldn't I just make the variable public? Well, we'll see in the future, there are very good reasons to keep instance variables with private visibility, and that means you have to write a method that can give you access to that variable in some way. So we can see all we're doing, this is a getter that returns the name instance variable of this student object. I've got a method, setScore, which takes, again, two parameters, just like we saw before when we were considering it from the client side, int I and int score. So two ints, and they have to be in that order. No return value here, so its return type is void. All I'm doing here is saying, if I want to change test1, that is, if the parameter that was passed in, I, is 1, then set test1. Otherwise, if it was 2, change test2. Otherwise, in all other cases, change test3. I've omitted the curly braces, and my indentation is a little hard to see here, but consider it to be there. This is a setter that is changing whichever test score you want to change. Here we have our getter for the score. It's doing roughly the same thing, except instead of changing it, we're returning the particular test score that we get as a parameter. So this has a return type of int, in contrast to void, which we saw with the setter, and we're passing it a single int, which again, we're calling I. So if I is equal to 1, we're returning test1, otherwise test2, otherwise test3. This is our getter for the test scores. And again, we have to have a getter because our instance variables are private. Outside clients can't access them directly. They have to go through our public getter. Okay, something a little bit interesting here. We've got the getAverage method, no parameters, and it returns an int value. So I declare an int variable called average, and in that, I calculate the average of those 3 test scores. You can see, again, I'm able to refer to these individually, even though they weren't declared in here, because those instance variables are accessible throughout this class. I calculate the average, store it in average, and then just return that value. If I wanted to, I could skip assigning it to a variable and just return this whole thing. That would work fine. It's just for clarity's sake, I assigned it to a variable average. Almost done. I've got this method, getHighScore. No parameters in here. It does return an int value. In other words, it'll be the highest score. Take a second and pick through the logic here. We start by declaring our variable high score. We assume it's going to be test1. If test2 is better than our current high score, which again we assumed to be test1, then we'll reset high score. And we'll do the same for test3. If it's better than whatever the high score was at that time, then we'll reset it. And at the end, whatever's still in the variable high score, that's what gets returned. So please, please, please do make sure you take a little time and pick through this. And our last method, the toString method. We can see that it takes no parameters here, and it does have a return type. It returns string. All methods, in fact, other than the constructors, have a return type, whether it's void or some other type, but this one returns a string. So remember, the toStrings job is to basically return a string representation of this particular object. So here we're storing that representation into str. And all we're doing is saying, well, give me name, colon, and then the name instance variable and a new line. Then we're doing the same for test1, test2, test3, and we're doing the same for average and including a call to get average. Now, notice, normally when I call a method, I usually have to have an object and then the method name. Here, I called getAverage without having some object dot. We'll talk a little bit more about why that's allowed in the future. For now, if you're really curious, just know that when you call a method that's inside this class, it's as if there is an implicit this dot in front of it. That's literally the word this and then dot. So that would be like this dot getAverage. We'll talk more about the keyword this shortly. But returning to this method, the concatenation here is a little complicated, so please do make sure you take a second and pick through it, make sure you understand what's going on. To summarize, for all these methods, what's happening is some client is sending a message to this object saying, hey, call this method with these inputs, and right then at that moment, the object activates that method. Then it manipulates the object's data or whatever's inside there using those instance variables. Now, we sort of glossed over constructors before. Again, let me reiterate, the job of a constructor is to initialize the instance variables of some new object that you just instantiated. And they only get called when you use the keyword new. So you can see every time we've made a new object, a new scanner, a new student, whatever, we've always been using the keyword new. Here's an example of a constructor. It's a little different from the one that we used before, but here we're making a new student object, and we're giving it the initial values Giovanni for the name and 81, 90, 97 for the 3 test scores. We're assigning it to a variable S1. So now that new object S1 has these 3 instance variables. Now, as I said before, the constructor that I called here is different from the one we had seen. The one we had used before, and the one whose code we looked at in a few slides ago, didn't take any parameters. It was empty in the parentheses. This one takes a few parameters. What that shows us is that a class can have more than one constructor, and each constructor has to have its own unique set of parameters. What's important, though, is all constructors have to have the exact same name, which is always the name of the class. So you can see all student constructors, all constructors of the student class, have to be called student, but they're differentiated according to the parameters that they take. The constructor that we saw before in the slides, the one whose implementation we looked at, that took no parameters. So we often call that the no-arg, or the default constructor. That's for constructors that don't take any parameters. If you write a class and you don't include any constructors at all, the Java virtual machine is going to provide a very, very primitive, basic default constructor behind the scenes. So that's if you don't define any constructors, then it's going to give you just a no-arg constructor. It's going to set up all numeric instance variables to 0 and all object variables, instance variables that is, to null, which is going to show us that the object variables don't reference any objects. But if a class contains even one single constructor, then the Java virtual machine will no longer provide a default constructor automatically. Then you may have to make sure that you define all your constructors as needed. Actually, it's best practice to always define your constructors and not rely on the JVM to do that for you. Let's illustrate this idea by adding a few constructors to the student class. Now, we already saw the default constructor from before, but now we can look at it with fresh eyes. The job of the default constructor is just initializing those variables to the empty string or 0. This is a little different from the default or no-arg constructor that the JVM would give us, because here we can see name is being initialized to the empty string rather than to null. I could add another constructor, this one taking 4 parameters. This is the one that we saw called a few slides back with the name Giovanni. This one takes a string nm and 3 test scores T1, T2, and T3. And then all it's doing is saying, hey, whatever values you passed in, just assign those directly to the instance variables name, test1, test2, and test3. That's helpful because it gives us a chance to initialize all those instance variables straight from the constructor. Then we don't have to have individual calls to set name and set score for all those different variables. Here's a third constructor. This one might look a little strange. This one also takes a parameter, but it takes only a single parameter. And that parameter is a student object, which we'll call S. So in order to call this constructor, in order to construct a new student using this constructor, you got to give it another student object. And we can see what it's doing. It's saying, hey, this object that you gave me, S, get its name, and then assign that to this new student's name. Get its score 1 and assign that to this student's test 1, and do the same for test 2 and test 3. Essentially, we're saying, hey, make me a new student object, but make it a clone of this other student object that I'm giving you. It's kind of nice to provide this variety of constructors because it means that when we need to make a new student object, we have a bunch of different options to choose from based on what we have. In this case, I could just make a default student object. I could specify all of its instance variables right up front, or I could say, hey, I've got this other student object. Just clone it. Give me a fresh copy of it. Last topic for the day. When our class actually does include several constructors, we can simplify the code for them by using a technique called chaining. We can chain our constructors. So as an example, all of the constructors that we just looked at, all 3 of the student constructors, they all do the same thing. They just initialize the instance variables. So we can simplify our code for the first constructor and the third constructor, and that'll make more sense shortly, by calling the second constructor from them. To do that, we're going to use this special notation using the keyword this, and then passing it parameters as if it were a method call. That's how we'll call one constructor from inside another constructor. Let's see how we would actually use this to rewrite those constructors. Okay, here on the left, we have our original constructor code. We see our default constructor, the one that takes all 4 parameters, and the one that takes a student object and clones it. If we use this, here's what we'll do. We'll say, hey, you know what? This is sort of the most inclusive, so I'm going to go ahead and leave this one intact. There's no change here for this middle constructor. Still takes 4 parameters, still does each one individually. But if I want to call that constructor from my noarg constructor, my no argument constructor, I can say, okay, well, hey, just do this and pass it as a parameter empty string 000. Now, when that's translated to bytecode, that essentially means, hey, call the other student constructor, which takes these parameters, and it knows where to look because, look, this is the only one that takes those specific types of parameters in that order. So it's almost as if we're passing on the responsibility for initializing the instance variables to this student constructor and just calling this one with empty 000. Same thing is happening here with this one. We're just calling this constructor using the this keyword, and we're passing it s's name, s's score 1, s's score 2, and s's score 3. This isn't required, but it is kind of nice because it means that now there's only one place where we would want to look for a mistake if we're confident that this is working and this is working. We can sort of always trace the ultimate work of initializing the instance variables back to this constructor. Not required, but a nice little feature. Again, this is called chaining constructors. So much covered in this lecture. I hope you didn't watch it in one sitting. Instead of just reading through this list, I implore you to pause this video and just read through these questions. Take a couple minutes and just actually write out answers. That would be a good way to check your own understanding here. If you can walk away having answered these questions really clearly, then you're in great shape. This is one of the most important lectures of the year, so I really hope you take the time to piece through it and rewatch parts of it if you need to. That's all for today.